Good evening, everyone, and welcome to the June 5th, 2026 meeting of the Royal Astronomical Society of Canada, Ottawa Centre. A special welcome to all other centres who are watching online or may be here. Welcome everyone, both members and public, who may be joining us in the theatre tonight and online. And we're having trouble with moving the slides forward. There we go. Ooh. We are recording this webinar for posterity. It's available on YouTube, if you know how to find us. For those of you online, please use the question and answer to ask any question to the speaker. Chat box comments can be seen by all, and raise your hand is disabled. The RASC Ottawa Centre acknowledges the trust placed in us by our First Nations with their ancestral lands and sky, and being able to enjoy it together with them. Tonight's program, I'm Jonathan King. I'm the assistant meeting chair. Paul's not here this week, so I'm filling in for Paul. I'll be your host for the evening. Dave Chisholm will be speaking to Ottawa Skies for June. Mark Lilienthal has got an excellent presentation on what did the ancients see in the sky. We'll have a short break after that. Then I'll be doing my much requested Frontiers of Astronomy, the Alien Fascination, followed by our observation reports. Richard will do our monthly observing challenges, and we will wrap up. Welcome new members in May. Karina Anderson, Brent Laundrie, Hayden Topazani, Ari Bolin, Philip Oles, Gregory Fitzpatrick, Dharma Rue, Owen Hanna, and Lee Stratton. Do we have any new members, any of them in the audience tonight? Let out a howl if you're here. Did I hear yes? No? Okay. 24 new members so far in 2026. Welcome. Members in the news. Oscar, I can always get Oscar's last name wrong. Dave, help me with Oscar's last name. Echeverry, thank you, is in the news because our calendar this month of June features a beautiful picture that he took of the Cygnus Wall. All right, our Fred Lossing Observatory, and for those of you who aren't familiar, we'll be talking about that a little later this evening. The gate and the building will be undergoing an access code change. The new code will be announced via email on Monday the 22nd. Oh, we're getting a bit of reverb. If you have any questions or concerns, contact Rick at flow@ottawa.rasc.ca. Okay? Yeah. Yeah, I'm muted here. Just hang on.
I'm hearing that.
I turned the speakers off on mine, and I think we're good. Okay, sorry about that. Ottawa Skies for June. Dave, if you want to come down and tell us the Ottawa Sky.
Well, I brought all my notes with me and promptly put them down someplace here. Anyways, it's not too complicated. So the moon phases, the full moon is on the 29th. Our new moon is on the 15th. The full moon is also called the strawberry moon. Maybe we'll get some strawberries soon. The days are getting longer. Of course, the 21st of June is the longest day of the year in terms of sunlight. And Mercury is at the greatest eastern elongation on June the 15th. Look for it low in the western sky just after sunset. And that's the same night as the new moon, so you should be able to see it quite clearly. The moon won't be in the way. Venus is visible in the early evening. Mars is visible before sunrise. Jupiter is visible in the early evening. Saturn is visible before sunrise. Uranus is visible before sunrise, as is Neptune. And here's our cartoon of the month. That's never happened to any of us, has it?
Now I think I know what my problem is with my telescope. All right, thank you, Dave. Now, for our first presentation this evening, it's my pleasure to introduce Mark Lilienthal, who is going to talk about what the ancients did see in the sky and the curious field of astroarchaeology. So, big hand for Mark.
So I'm going to start by doing something I was told you should never do for a presentation, that is to apologize. My voice is what it is. There's nothing I can do about it. The good news for you is that when it dies, I have to finish, so this won't go very long. So there's something in which I've always been fascinated, but I'll do a preamble here first. Since joining this group, I've noticed that there's something of a tension within it between what you would call the scientists and the artists, or those who are engaged in the science of astronomy and those who take pretty pictures. I'm a pretty picture taker. You'll see one of mine later, if I last that long. But we are all, we all do certain common things together. We scramble around looking for clear skies. We scramble around looking for dark skies. We spend an inordinate amount of time setting up and shepherding equipment, taking readings or taking photographs, and then spending a ridiculous amount of time afterwards processing all of that data and then proudly showing off the results. And that's what we do. I fear that what we forget is what it is we're actually looking at. And here's where my fascination, my personal fascination comes from, in that when I'm out late at night walking the dog, in our neighborhood the sky is dark enough that you actually can see stars, and on a good night you can actually see Milky Way. I often look up and go, well, I know what these things are. I know the physics. I know that stuff. But what does someone who knows nothing about that, what do they see? What do they think? And I think back to ancient times and go, what did they see when they looked up? What did this mean to them? So that's the little that's the travel I want to take with you tonight. Now, before we get too far down that road, I'm not even going to try to pronounce the name of this. There's something hardwired into all of our brains to see patterns. If you look at unorganized data, unorganized dots, an ink blot, you see something. The brain is wired that way. All of our brains, all the way back to our ancients, they could see patterns. That's built into us. So, okay, I'll just get on with this now. So, what I want to do now is I will ask you to follow me on this journey for at least a few minutes. Set aside everything you know about the heavens. Set aside all your astronomical knowledge. Set aside all of your knowledge, and just blank it all out. And just for a little bit of fun, let's do a little bit of time travel. I want to take you there. I think you recognize where that is. And furthermore, I want to take you there 7,000 years ago. Good to go? The other thing I should say up front is that, at least in my own experience, I don't mind being interrupted. If you've got a question about something, go ahead and do it. I know we don't tend to do that here, but by all means. So, 7,000 years ago, that's kind of what you saw if you looked around. In that part of the world, 7,000 years ago, it was a little wetter than it is today. There actually was water on the ground in many places, more like a savanna than a desert. And now, another thing about that part of the world, 300 days a year, clear skies. Want to move there yet? 300 days a year. And absolutely no light pollution. Sounding good yet? So, you are part of a tribe. Your tribe is, I'm going to say, semi-nomadic, in that you tend to stay in one place, but a couple of times a year the herd of cattle is moved to another place. And you're curious about things. You notice stuff. And in your spare moments, you notice that every day the sun rises. And if I was better with graphics, I'd have a little sun rising over one of those hills right now. Imagine the sun rises. But as time passes, you notice that the place where the sun rises seems to move. And you say, that's kind of curious. And you keep that in the back of your head. And then you notice that at one point, the sun goes as far left, and then it starts moving back towards, or as all the way to the left, and then it starts moving back to the right. And then it gets to a certain point, and then it starts moving back again. Now, you are, as I said, you're the curious sort. You keep records of this, I don't know, by scratching in the sand, maybe. And you bring this information to the elders. You say it's about 360 days the sun seems to do this. And the elders look at you and they say, hey, get back to work. Look after the herd. There's stuff on the ground there that needs shoveling. Get back to work. But then you go, but you know that when the sun gets as far left as it does, the rain season comes. And the elders, what? Because that's kind of important to the tribe, because when the rain comes, these lakes get replenished. It allows the herd to be moved around through the desert. So that's kind of important. So the elders go, okay, we'll give you an extra few minutes a day to keep more accurate records of this, because if you can tell us when the rain is going to start, that's kind of important to us. And they do that. And then over a period of time, God knows how long, the tribe gets together and you plant stones in the ground. That there's some kind of a marker in the stones that allows that when the sun reaches that magic point in the sky, it lines up between a bunch of stones. So I take you to this. That site, although that's the site now, that what you're seeing here is a recreation of the actual site. Those stones were found in the desert under sand, in that configuration. It's that one. Yeah. These stones here seem to line up with what we know as the summer solstice. And that particular site, through carbon dating of ashes that were underneath the stones, is dated to 7,000 years ago. something before, in the order of 5,000 BC, long before Stonehenge. So this is your tribe. Let's fast forward a little bit. Let's fast forward about 3,000 years. We're now in the heady times of ancient Egypt, what we call ancient Egypt, the time of the Old Kingdom, when those things were built. And the summer solstice for the Egyptians was just as important as it was for their ancestors who lived further down south, because the summer solstice coincided with the flooding of the Nile. And if you know anything about Egypt, once a year the Nile floods, the land becomes fertile, the crops grow, the crops are harvested, the land floods again, and that's why there's people living there. The Egyptians very much, well, we know they worshipped the sun. Their key deity was the sun god. Yep, good. East was very important to them because that's where the sun rose. Short detour here. In all of our languages today, the root of east or ost or whatever language you're in tends to work its way back to the sun. And more oddly, south was considered the right hand of. So as you face east, your right hand, and of course we are all hardwired, most of us, to be right-handed, so right is more important. South is more important than north. I'm sure Mick, if he's listening, will appreciate that. But back to the Egyptians, east was important, the solstice was important, and of course the invention of the sundial. Now this particular example, again, comes from that time. You have a gnomon. Am I even pronouncing that right? I don't know. The thing that sticks up in the middle casts a shadow, and that gives you information. This is what most of us would think of if you were asked about a sundial. This is a simple diagram. You've got, of course, the morning sun, the afternoon sun. You see the interesting shape of the gnomon here with this bifurcated top, which allowed a more precise determination of when the sun was actually at zenith. Or, sorry, not at zenith, but on the meridian. Therefore, your midday shadow gives you a meridian line and gives you north. Why that's important, there's again a slight detour I'll take in a couple of minutes about why that's important, why finding north is important this way. Now this is just a diagram, but here is a representation of something found scratched into a wall. In the center you can see that gnomon with the bifurcated top. The character on the figure on the left is the god Min, who was, amongst other things, the bringer of rain. And the figure on the right is the king. And this particular diagram is believed to represent the god Min gifting a means of determining when the rain would start to the king. But of course, this is an astronomy group, so let's stop talking about the sun. Let's talk about the night sky. What I've done here, this is plus or minus what the night sky would look like in ancient Egypt about 2,000 years ago. More or less with what you would see from the stars and the Milky Way and everything else. You've got, this is from Stellarium. You've got all the way from west through south over to east. But it's an idea of what the sky looks like. Again, remember, clear skies and no light pollution. We can only wish. Now, this is what the north sky looks like on that same day. And the date I picked for this, for what it's worth, which you probably can't read at the bottom, is the 5th of June, 2027 BC. And sometime about this time of day. Curious thing about Stellarium, if you actually want to try this, in the little window at the bottom where you put the date and time in, it will allow you to put a negative year into that. Sadly, Stellarium believes there was a year 0, so I'm off. But this says minus 2026. It's actually off by a year. Not the point. What you notice down here is that, or perhaps what you don't recognize immediately, is many of the constellations, because they're not where we remember them to be. So I've added in this next slide, I've asked Stellarium to draw the constellations, and you can see how low in the sky the Ursa Major is. And Polaris seems to be way gone over here to the right or to the east of north. To go one step further, once I had the equatorial grid, you can see here now how far off of north Polaris actually was 4,000 years ago. So to go back to something I mentioned earlier, having a means of determining north without reference to the sky at night was important. So to go back to put us into this position, remember, you know nothing about what these things are, but you're at an observation place, and there are actually diagrams that show this, where here's the gnomon in the ground with some kind of a seat in front of it, so that an observer could sit with his back to south looking north. So that's what you're seeing. And of course, over the period of the night, you notice that the entire sky seems to revolve around what you know to be north, or what you've determined to be north. The sky rotates. And over the period of 20, when you come back at the same time the next night, the stars start in the same place and they go around again. Over the period of a year, you notice that the entire sky rotates once as well. And again, very curious this. But again, so what? Well, at that time, the star Sirius, which of course is extremely bright and obvious in the sky, Sirius tended to rise at about the same time as the sun, close to the solstice. So now you had another way of determining when the solstice was going to occur, and again, to get ready for the flood. But okay, let's now step back for a minute, and you've got all the you see these things moving around. You also see that there are other things up there that move differently. What did they actually know? So we're going to move forward a little bit, about 500 years to this character. This character's name was Sennemut. He was not royalty, but rose to the ranks of a, check my notes, he was appointed high steward of the pharaoh, Hatshepsut. He was actually an architect, and he was credited with the design of that temple. Kind of neat. Because of his position in the kingdom, he was allowed to build his own tomb and his own mortuary, to which this here is the entrance. And that I wasn't able to find out exactly where that is in relation to the other, but it's very near. It's in the same specific area. Now, doesn't look like much from the outside, and frankly doesn't look like much from the inside either. There's two chambers, this being the first one that you would enter. But look at the decoration of the ceiling. You can see there's a lot of stuff up there. This is the actual ceiling of that chamber. That's what it looks like today. And sorry, by the way, it's closed to the public now. This is called an astronomical ceiling. It's not unique at all to Egyptian mortuaries, but this is the oldest known one. Oldest in that it is dated I was sure I had the date in there. It was it's about 1570 BC. And it's dated that way because of the knowing when Hatshepsut reigned as pharaoh. This is a drawing that has been made of the photograph. There's actually two halves. The southern half is on top, the northern half is on the bottom. This is the northern half. Sorry, the southern half, the top of the diagram you just saw. So what are you actually seeing here? From right to left represents 35 of the 36. They're called decans. You need to understand a little bit about the Egyptian calendar. The calendar had 12 months. Each month had the 12 months. Each month had a decan of 10 days. So that's what these. Now there's only 35 of the 36 listed, but what's written top down is the name of the decan, an indication of how many stars were represented in the constellation that would rise at the beginning of that decan, and then the gods associated with it. So what you've got here is a calendar which, if you knew what the constellations were that are being discussed, And sadly, we don't know what constellations these were. This would tell you that when this star is rising, you are at the beginning of that decan. That's a calendar. This character here in the center is Orion. Next to Orion is Isis. Then you have two somewhat smaller figures. These are what they call the exterior planets. And in order, you have Jupiter and Saturn. Some of this writing at the top, Jupiter, Horus, who bounds the two lands in his name, a southern star of the sky. Jupiter. Saturn, Horus, bull of the sky, the eastern star which crosses the sky. That's what's written here. And then you have a number of spare decans. And I have no explanation for what those were about. But then over here on the far left, you can see that there's a figure at the bottom, but there's two columns at the top. That represents Mercury and Venus. The next thing, all this writing at the bottom, you see 5 lines here, and when I flip to the next one, you see there's more lines at the top of that. Those are all prayers on behalf of the man. So, next slide. So this was at the top. This is the bottom. And there you can see, of course, the continuation of the prayers. Now, what are you seeing here? The 12 circles are the 12 months. And the way they're inscribed here, these 4, again, this all works right to left. These 4 circles represent the first season. This was the season of inundation. I'm not going to try to pronounce the Egyptian words just because. These 4 are the emergence, and then these are low water, 3 seasons. Curiously enough, each of these is divided into 24. But again, there's no explanation for why they're divided into 24. Across the bottom from both sides are a number of, those are simply protective gods. Each of them is carrying the thing on their head is a solar disk. But I draw your attention to the figures in the center. Those are a little hard to make out. This represents what they are, and all we can say for certain is that represents Ursa Major, or at least the plow part, what we call the Big Dipper. It's believed by some that this represents Draco. And apparently that's supposed to be a hippopotamus with an alligator on its back. So I go back to the thing I said about seeing patterns in the sky. They looked up, and what we think is a dragon, they think is a hippopotamus with an alligator on its back. I'm not going to question that. I can't even see the dragon sometimes. So, next step. But what happened to Mars? if they knew about Venus and Mercury and Jupiter and Saturn, why was Mars missing from that diagram? So this particular diagram, and you can see how it's very similar to the other one. This particular diagram was made 200 years after the first. This is on the ceiling of the tomb of Seti I. And I didn't mean to do that yet. If you look here, you can see where here was Orion, there is Isis, and there are 3 characters beside Isis. And the rest of it is the same as the other. So now, put the two of them side by side, or one above the other, I guess, when you look, and you can see that there's just one missing. Mars just isn't there. Something else you might note is that if you look over here, each of these characters is in a boat. On this side, there's an empty boat. Over here, the boat is filled. So what are we to make of all of this? And that brings me to thoughts about what some call archaeoastronomy and what others call astroarchaeology. They can't even agree on what their name is. But it's the attempt to make sense out of these things from an archaeological point of view. And at this point, I'll back up and say, my main source for this and everything I've been saying about these comes from an historian of Egyptian science, of ancient Egyptian science, who personally translated the documents. And not an astronomer at all. He simply reported what was written. I found another article which claimed that Sennemut must have been an astronomer because he had this thing painted on his ceiling. Sorry, chiseled on his ceiling. And tried to make that particular author made a great deal of the fact that Mars was missing, because at about the time of this, Mars was actually in retrograde. And so he thought that the empty boat was actually Mars, and it was invisible for some reason because it was going backwards. Then he goes on about and the reason for lining the planets up is because in 1535 BC, there was a really significant conjunction. So he believed that Sennemut had seen this and had this somehow immortalized on the ceiling of his tomb. For what it's worth, that what am I saying here? This is the 3rd of March, 1535 BC, and you can see Jupiter, Venus, Saturn, Mars, and Mercury in a neat little parade in the western sky. But my point here is that all of this is based on fragments of documents that are written in dead languages. The Nabta people who built that stone circle, they left nothing behind. All that we found of them was those stones. In ancient Egypt, the literacy rate, again, different sources, but I saw numbers as low as 5%, as high as 15%. Most Egyptians could not read or write. So my simple brain goes, what happened here? Well, remember, this is chiseled into a ceiling. Someone's in there, tap, 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 with a mallet and a chisel. They've probably been given a papyrus that has this diagram on it. This took them many days to actually do the work. Do you think they got it exactly right? Why are there only 35 of the 36 months? Well, they missed one. What happened to Mars? Well, it was probably a Monday and they woke up badly that morning. I think we read too much into minor details like this if we don't put the entire thing in context. So, where I want to end here is all of our notions of time come from astronomy, come from astronomical observations over millennia. The more I dug into these things, every time I turned another page, they were talking about time, be it calendars or hours of the day. The ancients looked at the sky as a calendar. It was their calendar. The sun and the stars were their clock. And if sufficiently motivated, sometime in the future, maybe I'll do another talk and see where these things, and try to answer a few of those questions. Why 12 months a year? Why are there 7 days in a week? Why 24 hours in a day? And the best one of all, why does Easter move around the way it does? If you don't know, I'll tell you later, but it's bizarre. So, today, we see the same sun, we see the same stars, we see the same sky that our ancestors did. My challenge to you is the next time it's a clear night, which sadly I don't think is tonight anymore. The next time you're on a clear night, you look up, forget everything you already know, and just go, what is it that I see, and what did that character 7,000 years ago, 4,000 years ago, what did they see when they looked up? Because it's the same star and the same skies and the same everything else. And at that, my voice lasted. Thank you very much for your attention.
Thank you, Mark. Any questions for Mark? Chris, do we have any questions online? Or maybe turn the lights on. We'll see if we've got any questions in here.
You just put some room lights up a bit.
Any questions online, Chris?
No.
Okay. How about in the audience? It's dark in here, so if you got a question, yell it out. Just a sec, I'll give you the mic. Whoa, I'll give you the mic.
Hi, Mark. I wanted to ask you, when were the constellations named, and was it during the Roman times, since most of them have Latin names? Any ideas about that?
The constellations, as we understand them, come from the Greeks. The Greeks in the Roman time, yes.
Okay.
So, of course,
But when you say that one of the representations was Orion, how did they know that was Orion if it was named?
no, that wasn't the constellation Orion. That was the god Orion.
Oh,
And a particular star, although which one we don't know. Because I skipped a step inside the Orion was on that center. Immediately left was Isis, but also representing Sirius, the star Sirius.
Okay, thank you. Any other questions here in the audience this evening? No? Oh, way over there. Okay, I'll bring you the mic so that the people online can hear too.
Yeah, I read once that the location and sizes of the pyramids has some relation to the like asterism we call Orion's belt. Is that at all true, or is that just?
I don't know. I wasn't there. I think that fits into the category of we read too much into coincidence. It is true that the pyramids themselves are very much aligned north-south. But that is believed to have more to do with the entrance faces east. And, well, if the entrance faces east, that wall is facing east, therefore that wall is running north-south. But if you think back to the slide that showed where the constellations were 4,000 years ago, they're not where they are now. I'm sure you know the precession of the equinoxes. Some of us grew up in the age of Aquarius. Well, that was Aquarius rising, but these things move. So I think that's coincidence if that, but it has more to do with having the pyramids face east. East was all important to them.
All right, thank you. Any other questions tonight? No? Well, thank you very much, Mark. Appreciate it.
Thank you.
And we're going to turn it over to someone who's online tonight. Sharon Odell is going to give us a little bit of an update on the Dominion Observatory campus on Carling Avenue, right next to where they're building the new Civic Hospital. So I'll turn it over to you, Sharon.
Hi. Can you hear me?
Yep, you're good.
That's good. Tomorrow's event is for Doors Open Ottawa, and it's at the Dominion Observatory. And we've done this a few years in a row. We've had good weather all the other times, but tomorrow looks like a forecast where the weather is not going to keep our lucky streak. There's about a 40% chance of possible showers in the morning, and of course in the afternoon after 1 o'clock, some stronger rain. So we may not have the solar viewing as we would have liked, but we'll make a more of a decision first thing in the morning. But we will go ahead with the education and a couple of tours. This year, we're celebrating the 124 years of the Dominion Observatory campus. It was started to be constructed, the building number 1 observatory that you see there in the slide, between 1902 and 1904, and was definitely opened by 1905. And the last building was built in 1917. Last year in 2025, it was designated as a National Historic Site. So the campus itself, the campus of all of the buildings. In 1991-92, the main observatory building and the separate buildings were designated as heritage, but not the entire campus. And so we will still be educating about that. Next slide, please. This is the Doors Open advertisement, and just wanted to highlight that the Dominion Observatory campus is listed there between 10 a.m. and 3 p.m. Access will only be outside, and the buildings aren't open again this year because they have been leased. So this is good news for keeping the site running. But of course, for an event like this, it's not the best. But the campus is our main focus anyways, and so we will be giving education on that and education on light pollution this year. The time in the schedule is between 10 a.m. to 3 p.m., but we will be on site until 4 p.m. But it is advertised from 10 to 3. And I also wanted to highlight the Ottawa Hospital's new campus. Some have asked whether there will be information about that too, because there's a large construction site around the observatory. But that will be happening at City Center Avenue. If you want to hear more about the construction and to ask questions about how it'll affect the Dominion Observatory campus. Next slide, please. This is just a reminder of the times it's open from 10 a.m. to 4 p.m., rain or shine, and it's outdoor access only. Again, the solar viewings are definitely weather dependent, so can't depend on that. The guided tours will only be between 10 till 11:30 a.m. on the history of the Canadian astronomy program that was there. There's also new light pollution education as well. And there's the list of the RASC Ottawa Centre volunteers that will be there, except for the solar viewing, then they may not be there. But the rest of us will be for the education. Thank you.
The second part of our meeting tonight. Benefits. Becoming a member has its benefits. The biggest benefit is getting to hang out with a lot of cool astronomers who are at various stages of learning how to look at the sky. People who know me know that I'm pretty much an amateur at all this, but I'm having a lot of fun. And so that's one of the big things here is that we've got people with all sorts of experience, range of what they do, whether it's astrophotography or visual, looking at the sky, whether they're big into looking at the sun or the night stars. There's a lot of people with a lot of varied experience. Also as a member, our Ted Bean Loan Library. Peter runs this, and the great thing about this is you can try out a telescope before you go out and spend some serious money on your own telescope. We have the Fred Lossing Observatory out of the Milliken Tail. It's been there for many, many years. I remember going there when I was 17 years old, and I'm 19 or 20 now. We have 3 large telescopes there that you can be trained on and are available for use by the members, or you can bring your own telescope out, and we'll talk about some of the meetings out there. As well, we've got our book and disc library. We talk about Estelle's pick of the month, but Estelle retired as our librarian. We have new librarians who have stepped into the role. Also, our Astronotes, our RASC Journal, and our Observer's Handbook are all fantastic reference material that the membership receive. And as well, we have our Discord server, which a lot of the members post a lot of their astrophotos online. And there's also help there in terms of members helping each other on various questions around telescopes and stuff. And you get a free access to Astrospheric Pro, which gives you all weather prediction stuff, which, as we all know, cloudy skies have been the bane of our existence lately. And so knowing when it might be clear is a fantastic thing. Membership costs, a regular membership for an adult is $118 a year. If you want a family membership, the base amount is $112.50, and for every adult and youth, it's $18 and $10.50. And if you're a student or a youth, it's $77.40 a year for membership. You join online at our national website at www.rasc.ca, and then you select Ottawa Centre as your local RASC Centre. All right, I'm going to have a bit of fun tonight with my latest Frontiers of Astronomy. For those of you who might have been here in the fall, I did a kind of a preview on all the different topics I'm looking at presenting over the next couple of years. One of them was the alien fascination, and I've had a lot of requests to do this one. So we're going to have a bit of fun tonight. I'm going to mess with your head a little. Don't necessarily quote me for facts because I don't know if some of the stuff is necessarily true or not, but we're going to have a bit of fun, and I'm going to leave you with something to think about when all is said and done. All right, so this is all about the existential question, are we alone on planet Earth? So alien culture pervades our media, our lives, and if you're spending a quiet Friday night, it's not a Friday with a RASC meeting. You can sit at home and pick up a magazine, tune in to the Alien channel on your 4,000 channels that you subscribe to. Or if you want to get out and have some fun, yes, you can go to an alien festival and even get up and dressed up and cosplay there. You want to dress up like an alien? Guess what? You know what? People won't look at you that funny anymore if you walk around like that. Or, you know, there's even the potential to stay at the little Alien Inn. Alien. Regardless, we see them everywhere. Whatever you do, just wash your hands. Thank you. All right, let's go way back in time. About 15 years ago, when this TV show hit the airwaves on the History Channel, and I think it's their bread and butter and keeps them out of bankruptcy, and the show's called Ancient Aliens. And if you haven't had the chance to watch it, it's a lot of fun, especially after you've had a couple drinks. It really starts to make sense. So let's talk about some of the favorite topics from the Ancient Aliens channel. First, the Hopi Star people. All right, so this is where I'm going to have to start looking at my notes, or I'm going to skip over a lot of stuff. So the Hopi people are an interesting tribe in southwestern United States, in the Arizona desert. And they've got some really cool rock paintings of people with big heads and big eyeballs and antennae and stuff like that. I don't know, could be aliens, maybe not. Their mythology, though, is interesting. They believe that their ancestors live in the stars, ride around on flying shields, and watch over them as protectors. Okay, interesting. We go back to ancient Sumeria. So civilization on Earth kind of popped up in what is now modern-day Iraq about 4,000 years ago, and that was the Babylonians, the Sumerians. And their gods, or set of gods, were people that they called the Anunnaki, who, as you see here, had wings and beards and funny hats and all that stuff. So make of it what you will. Were they angels? Were they just dudes with wings? Did they carry the wings around? Who knows? The Sumerians believed that the Anunnaki were gods that visited them on Earth and told a lot of interesting stories. But one of the interesting stories they told was this rogue planet called Nibiru that wasn't in the plane of the ecliptic, but actually had an elliptical orbit outside of it, and that this planet would show up every 3,600 years ago and come zooming in and generally cause catastrophe and stuff like that as it went zipping in through the inner orbit of the planets and messing up the planets. The interesting thing about all this is that today we look for the mysterious planet X, which we believe is on an elliptical orbit outside of the orbit of most of the inner planets and shows up every once in a while and maybe does some stuff. We know from the orbits of Pluto and some of the other dwarf planets that there's something out there messing with their orbits, and maybe it's another planet that we don't know about. Did the Sumerians know something we didn't know? Maybe, maybe not. Okay, so let's go to Christian type stuff. And so this is a painting that hangs in the Palazzo Vecchio in Florence, and it's attributed to a number of different artists, but it's generally believed to come from the 16th century. It's a beautiful painting of the Mother Mary, baby Jesus, and a little baby angel Michael there protecting the baby Jesus. But hang on a minute. You look at the shoulder of Mother Mary, and there's a bunch of people standing on the hill looking at something in the sky. At first, I thought maybe it was a blotch, a load of paint. But if you look closer, it's this craft with light shining out of it. So I don't know. What was the artist trying to paint into his painting 400 years ago? Something to think about. regardless of what you think, the answer, at least according to the History Channel, is it must be aliens. Okay, so let's take a step forward to more modern history, and let's talk about aliens and the Second World War. And we all often heard about things like Foo Fighters, when the bombers used to come from England and bomb continental Europe with fireballs and stuff like that. And it was probably electromagnetic stuff. But as we learnt as World War II went on, the enemy of your enemy is not necessarily your friend. And there was a lot of discussion towards the end of the war between the Americans and the British of what to do with the Soviets, because they knew there was another war coming. And in history we know, and for people like myself grew up through it, the Cold War was a real thing. So at the end of the Second World War, the American government undertook a very secret and very purposeful operation called Operation Paperclip. What Operation Paperclip was, and was started in July 1945, was basically to recruit, and that's a fancy word for capture and say, hey, you're working for us now, 1,600 German engineers and scientists and bring them to America so that they could gain some of the technological advantages that they saw on the Nazi side of some of the technology that had been used during the Second World War. One in particular was a famous, or let's say infamous person, who's an established war criminal, was an SS major, Dr. Werner von Braun, who went on to be integral to the U.S. space program and was the chief architect for the Saturn V rocket that put man on the moon through the Apollo program. So there was a lot of controversy about this program, but in fact it did provide the Americans with certain advantages when it came to participating with the Soviets, especially in the space program. For those who are older, they know that for the longest time the Soviets were ahead of North America, or the head of the Americans in terms of space, together with Sputnik, first man, first woman in space, and there was a lot of fear that the Soviets were going to be the first one to set foot on the moon. Operation Paperclip captured a lot of interesting technology from the Germans, and this next one here is going to mess with your head a little bit, because this is supposedly a U.S. Army intelligence photo taken in late 1944, early 1945. And the big question is, what are we looking at? It looks like a UFO. It's got landing gear. There's trucks sitting there working on it, and it has the straight-armed Iron Cross that was carried by the Luftwaffe in World War II. What to think about this? There are other photos of one of these actually being towed by a U.S. Army truck, a truck with a white star on the side of the door. And so, are these photos real? Apparently they are, but are they? Who knows? But interestingly, what you see here seems to look a lot like what UFOs tended to look like after the war. Okay, so let's take a step forward into a little more modern aliens. Let's go post-World War II and into the Cold War. So, of course, the biggest one that we all talk about, there's TV shows, there's movies, everything about it was in July 8th, 1947. This headline hit the daily record of Roswell, New Mexico. It said, the Army Air Force captures a flying saucer on a ranch at Roswell. Now, if you know anything about Roswell, it was very close to Walker Air Force Base, then Roswell Army Airfield, which was a major base for the U.S. Air Force Strategic Air Command, i.e. the bombers with the nuclear bombs. And so this happened right outside of there. Interesting. A few days later, the Air Force showed up with a bunch of tinfoil and said, hey, dudes, it was a weather balloon. I don't know what you guys were talking about, but we're talking about a weather balloon. Believe it or not. One of the things that was instituted about that time, because of a lot of sightings and people's concerns, was Project Blue Book. Project Blue Book being a U.S. Air Force investigation into unknown aerial phenomena. A couple pictures. This one was taken of supposedly a UFO in 1951 flying over Riverside, California. And in 1952, this is one at I have trouble pronouncing this one, Passaic, New Jersey. And I'm going to say, gee, it kind of looks like that German thing we saw. I wonder if you take a close look at this, if it has USAF star on it, and Maybe it's a U.S. Air Force UFO. I don't know. I don't have the answers. For some of us who remember the 90s, all the tales of the strange lights over Phoenix, which went on for, I don't know, about a week or two in 1997. But more recently, one of the things that the U.S. government's trying to do to distract from all their mistakes is release more photos about UFOs. And so one of the things they've been releasing is tracking video from supposedly some of the fighter jets chasing things in the sky that look weird. But if you were paying attention this week, they released one in the last couple of weeks, which I thought was pretty cool. This is a photo that Apollo 17 took on the moon. Hello, who's flying by with the three lights? I don't know. Was it a reflection in the helmet? I don't know. But there certainly raises more questions than answers. All right. So let's take a step away from the fantastical stuff into a little bit more science. So the Drake equation. In 1961, astrophysicist and astrobiologist Frank Drake wrote an equation that's become very famous now as to estimating the number of communicating extraterrestrial civilizations in the galaxy. So the number is equal to the rate of star formation in the galaxy, the fraction of stars with planets, times the number of planets per solar system that are suitable for life, times the fraction of those which actually contain life, times the fraction of those planets which have intelligent life, so clearly Earth is ruled out here, times the fraction of civilizations that release detectable signs of life, times the length of time that these civilizations release signals. So if you do the math on this, you should come up with a rough number of how many technologically advanced civilizations there are in the Milky Way. All right, so one of the things then science has been doing since about the 1950s, 1960s is SETI, the search for extraterrestrial life. And using radio telescopes, they've been listening to signals that come in from space to see, do we hear any that are clearly not stars or something else in the sky? I remember in the 1990s doing a project on my computer where the SETI group asked that everyone who has a desktop do some data processing, leave your computer on, run this app in the background, hopefully your internet bill's not too big, help us process some of this data. In 1977, Ohio State University captured a signal that lasted 72 seconds near the constellation Sagittarius that was of very high intensity that they labeled the WOW signal, which got its name from some astronomer circled it and wrote on it, wow. It did not repeat, and to this day we're not quite sure what it was. Maybe it was something. But together with the U.S. National Radio Astronomy Observatory and the SETI Institute headquartered in Mountain View, California, since 1984, they have been making a concerted effort to scan the night sky with radio telescope and see if they can't find anyone out there who's broadcasting reruns of I Love Lucy or get smart, right? Because if you look at it this way, aliens listen to us and they figure out how TV works, that's what they're going to be watching. So that's what we sent into space. Microbes in space. So a lot of discussion around how does life originate on Earth? And there's all sorts of ideas on that. And one of the ideas around is that comets act as superseders. And so you get a planet like Earth, and it has water on it, and a comet comes zipping by and leaves some of its comet tail and debris, or even hits the Earth, and it's filled with microbes. And maybe those microbes are what causes life on planets. Who knows? A theory, perhaps. We do know that certain microbes can actually withstand the vacuum of space and the heat and cold. And today, we do know that water is important, very important, and that is why in the present space race to return to the moon, the Artemis program, as well as the programs from the Chinese government and other groups, they're all focusing on the south pole of the moon because it's believed that there's ice in the craters that has never seen the sun, and not only provides the opportunity to have water on the moon for use, because we need water. As everyone knows, we are mostly water. But as well, we may find microbes in there on the moon. So we might actually have life on the moon. You never know. Okay, exoplanets. Exoplanets is a neat one, and we've got someone later tonight who's going to be doing some observations about exoplanets. So the first exoplanet was discovered in 1992, so we've been at this for decades now, looking at the way stars behave, and from that, using science to determine that there are planets around other stars. One of the big programs is called WASP, which is the Wide Angle Search for Planets, and it's discovered quite a few exoplanets. To the point now today, we've got so many exoplanets, it's believed that we have discovered so far just over 6,000 planets orbiting other suns. Now, if you go back to the Drake equation, well, that's bumping up the number potentially of intelligent civilizations out there. So is there life out there? Maybe there is. So what to do with all this? Well, and maybe someday we'll stand on a planet and look up to the sky and see something like this. So what to do with all this, right? First of all, keep an open mind. What I've presented here tonight, some of it's pretty wild. Is it true or not? Who knows? But keep an open mind. If this is how science learns. And when we go back to the days of Copernicus and Galileo, Galileo got persecuted for suggesting that the Earth wasn't the center of everything. Secondly, we really don't know much. We don't know much beyond what that person was standing in the desert that Mark was talking about thousands of years ago. We know more, but what we do know is there's a whole lot more to know. So a little bit of humility goes a long way. If we see something or we note something that doesn't fit into our belief system or our models, that doesn't mean it doesn't exist. It just means we don't understand it. We learn scientifically. The basic principles of science are to observe, investigate, record, report, share, draw hypotheses, put theories together, test theories, see if they work, see if they don't work. And that applies specifically to astronomy. The universe is huge. We understand so little of it. By using scientific principles, we can learn more and explain some of the stuff maybe that we don't know. Finally, stay curious. And that's the reason I think a lot of people are here tonight, is that we are curious. We look up to the sky with curiosity, with wonder, and to maybe learn more or be excited about what we see. Okay? All right. And as I always say at the end of Frontiers of Astronomy, the truth is out there. We just have to go find it. If you got any questions on today's presentation, that's my email at ottawa.rasc.ca. All right. So thank you on that one. Any questions or comments from the audience? Oh, Simon's got his hand up. I'll bring him the microphone. Chris, can we get the lights on?
Oh, whoops, that was unexpected. Well, that was a lot of fun. But I got really curious when you showed us that slide of the Sumerian solar system with their named planet, which was not in the ecliptic plane. Now, did I understand correctly that you're suggesting the Sumerians knew there was an ecliptic plane?
Well, there was a writer, I think it's Alexander Sitchin, who wrote a lot of stuff about the Sumerians, which people are having a hard time wondering if what he wrote was entirely true or not. But one of the stories that he did write about was that the Sumerians did talk about a rogue planet.
Okie doke.
Yeah, don't fall over. No, I'm a first aid responder. I don't want to have to do that tonight. Any other questions from the audience? Oh, one over here. Richard.
You showed us the Drake equation, and I've been sort of following this for quite a bit of my lifetime. And at first we knew nothing about any of those values in the equation, and yet in the last couple of decades, we have actually come up with a much, much better estimate for many of the parameters in that equation. So what is our best estimate at the moment for how many civilizations there might be in the Milky Way?
Yeah, great comment to the answer I don't know. And I'm not sure that a lot of people necessarily know better than I do, but as you said, we started to bracket some of these variables, and I think what it's starting to show is maybe there is the potential for a lot more than what we thought there was. Certainly there's a lot more planets out there than we had thought, because at first we were wondering, how many of these stars got planets? Now we're starting to get a feel for that. So I think there's a lot of work to do there yet, Richard, but I really don't have myself an idea of where the number sits. Do you? Nope. Okay. Anyone in the audience have an idea? One plus. Exceeds one. Okay. Any other questions in the audience? No? Chris, any online?
Nope.
All right. So we'll carry on with the rest of our evening. Thank you.
Just a comment online from one person that he thinks the number is 42. Thank you, Wolf.
Yeah, we'll have fun with that one. Okay.
I may be misreading this, but someone here is saying it's 15,600,000.
Okay, so one scientist out there took a stab at it, and 15,600,000 potential civilizations. Yeah, give or take 5, right? So, anyhow, hopefully as time goes on, maybe we'll find out some more. Okay, observation reports. We've got 5 people presenting tonight. I do want to speak a little bit on this one. There's been a lot of feedback to council, all great feedback. I just want to remind everyone that these are 5-minute segments, so please do try to keep it to 5 minutes. And by no means is this the professional portion of the evening. For those of you who are new members, for those of you who are youth members, maybe you've taken a picture of the moon for the first time with your cell phone and you're really excited about it. Don't be afraid to step in and make an observation report. A big part of this community is around connection with all the other astronomers, and to the extent that you have something that you're excited about and you share, that really warms our hearts. So don't think that you have to be a serious astronomer to do an observation report. Paul and myself, we're more than open to anyone coming up and presenting some stuff they're excited about. So with the first one, Jim, I'll turn it over to you.
Greetings, everyone. Okay. So this image of the solar disk I took some time ago to bring some of the details on the surface, including the filaments. I used the tone curve histogram on a program IMPPG to create what is called an inversion. So dark areas are light, and light areas, which normally are associated with higher magnifications, such as plazas and active regions, are dark. So what we're looking at here are the active regions, north and south, and you could see 2 of the sunspots, and here's a couple of more sunspots right here. And this indicates high degree of magnetism and possible eruptions. Another reason I took this was also to get a good look at the filaments. And these are the filaments. And the filaments show up really well when you're using inversion, the inversion technique. And the filament is really a prominence, but since it's located on the surface as opposed to the limb, it's called a filament. So the equipment and software I used here, I took a 2,000 frame video file, and I used AutoStacker to process the best 10% of 2,000 frames, yielding one stacked image. And then I used another program, IMPPG, to process the image, which basically helped to sharpen and clarify it. And then I manipulated, I don't want to get too technical about this, but I just want to say that in order to really get the inversion, I had to use a program to manipulate the histogram in order for that to occur. And in addition, I was also able to locate these prominences. And typically what I do is when I get one good image of the disk and I see the prominences, I pick one prominence to animate. So I'm looking at these prominences and I'm thinking, now that looks very interesting. And there's something that seems to be defying the rules of gravity. Well, when in fact it really isn't, but nevertheless I decided to process that particular prominence right there. And so what I did, all right, is I attached a 2x PowerMate camera, which really allowed me to hone in on this massive plasma, which is, in truth, it's buoyed by the magnetic field that supports it, suspending its mass from gravity is just another term that you could use for this. I used the same equipment to capture this particular image. In this case, I took several video files, one video file every 30 seconds for about an hour and a quarter. So that's basically an hour and a quarter of activity that you're looking at right here. And I've always found it interesting to see mass defy gravity and hover in space. But I noticed that on the sun, this is not an uncommon kind of event. So here is another example of that. And that's basically it, folks. Thank you very much.
All right, Adam, you're next. And there's an envelope here on the podium. Make sure you take it with you. It's from Chris, okay? Okay. And you know how to work this funny thing?
No.
Okay. This is forward slide, this is backward slide, and that's the laser pointer.
Okay. Okay, thanks. Yeah, so I wanted to present an observation I made as part of an educational program with an organization called Boyce Astro, based out of the States. It was a really fun program called their Exoplanets Explorer program. I'll mention them again at the end, just because I think it's, it could be interesting for people. They do a bunch of stuff, exoplanets, double star photometry, and speckle interferometry. We're doing one of those this summer. So I used their, we already had a good explanation of what exoplanets are. I used their telescope, which is at a dark sky site in the southwest. It's a plane-wave CDK 17-inch telescope, pretty sweet telescope. The observation, here's the field of view of the observation. It's so the point is that there's a star, HAT P12, and it has a planet that the orbital plane of the planet's aligned pretty much exactly with our line of sight on the star, so that the planet's going to pass in front of the star once per orbit. And the idea is to observe that star and look for fluctuations in its brightness. And the technique is to compare it with another star, which has a kind of a stable luminosity. So then, as whatever sky conditions change over a few hours, you you do the comparison between the two of them to see the variability of brightness. Yeah, so it's 195 exposures, 75 seconds per exposure, and here is the light curve that it produced. Each of the little points is one exposure, and the x-axis is time. This is about 3 hours in total. The y-axis is the relative flux, so it's basically the zero is the kind of steady state brightness of the star, and then as it goes down, as the average intensity goes down, that represents a dimming of the star. And of course, the idea is that as the planet passes in front of the star dims. And yeah, a little bit of, so there's this, there's this shape, there's a definite shape to it. There's it's a bit steep, and then there's this kind of broad bowl, and then it's a bit steep again coming out. And that corresponds, is claimed to correspond to the first contact is when the planet just touches the limb of the star, and that's where it starts to dim. It dims kind of rapidly as the planet fully enters the disk, and then there's a kind of a slow, steady phase where the planet's just passing in front of the star until third contact, where it starts to exit, and the star, the apparent brightness of the star increases again. And yeah, so there's a bunch of neat stuff that you can learn just by measuring the depth of the transit, the amount that the star is observed to dim, and then the kind of ratio of these different time periods between the contacts. The most obvious one, or the most basic one, is just that the size of the planet, the ratio of the size of the planet to the size of the star is directly measured by the depth of the light curve. So in this case, the light curve dimmed, the star dimmed 2.5%, and that means that the area of the planet, the apparent area of the planet is 2.5% the apparent area of the star, which means the radius of the planet is about 16% of the radius of the star, which is pretty big for a planet. And then there's other kind of directly measured parameters. This one's the orbital inclination relative to our line of sight, or this, it's a measurement of that. And this is the radius of the orbit of the planet relative to the size of the star. And so that's, so then the next thing, this is the fun thing for me, is you take that information measured from the light curve and then a little bit more data. This is the apparent magnitude of the star, its distance, which is 456 light years, I think. It's a 12th magnitude star. Its effective temperature is like 4,700 Kelvin, which is a little cooler than our sun. And then you could use that and these kind of observed measurements to calculate the properties of the system. So, my measurements, which were kind of like a naive methodology, was that it's just a little bit less than the size of Jupiter, the planet, and it turns out to have been put on the table here. The mass is a little bit less than Saturn. I measured its orbital radius to be 0.018 AU. It's thought to be more like 0.38 AU, which is like the orbit of Mercury. And then the temperature, in the 900s degree Kelvin, which is not like a super promising habitability candidate. But, totally open mind. There's lots of available energy, hurricane force winds, hundreds of degree temperature gradients. So, yeah, who knows? Oh, yeah, and just, again, a quick plug for the Boyce Astro, that they have a lot of really neat programs about it's kind of like citizen science, like amateur science type approach to astronomy. And I'll put the link to their website in the Discord later when I get home, in case anyone wants to check it out. Thanks.
Thank you, Adam. Next up, we have Bob. You're next. I see Bob approaching in the darkness. There's no rush.
Chris will run it,
Okay.
I hope. Just before we start, I got to make a comment about the talks tonight were really interesting. My wife is positive that aliens exist, and she made me go to Roswell when we were in New Mexico. And you know, you talked about the constellations where the stars are different now than they were 5,000 years ago. Some of it is from the motion of the stars, for sure. They move a little bit, but most of it's because the Earth is tipping and turning all around. So it's really mostly that. Anyway, tonight, this is one of the challenge objects, and it's a group of 6 compact galaxies. That's the one in the very center. Okay, next one. Also, it's got another galaxy just at the top, and I'll zoom in a little bit on those. Okay, go ahead. Next one. This is the top one, and you can see that I zoomed in enough that it's starting to look a little kind of grainy, but it does show more detail, or that detail's in the other image too, but you can't see it the way at the scale we looked at. Okay, the next one. This was probably the real challenge object, and it always kind of reminds me of a butterfly. And this is pretty cropped in, but there's quite a bit of detail in there. Okay, next one. This was is also a challenge object, and it's about 65 million light years distant. And this galaxy has an obvious central bar, probably more than anyone I've seen before. Okay, next one. This is M101, sometimes called the Pinwheel Galaxy, and it's about 21 million light years distant. It contains about 1 trillion stars and has a diameter almost 3 times that of our Milky Way. By the way, the trillion stars brings me to a point about the Drake's equation. One of the variables is the number of stars in our galaxy, or in the universe, if you choose that. And that's a monstrous number. So you're starting off with just a gigantic number to go. So it's pretty, the Drake equation suggests strongly that there is life outside of here. Thank you very much.
Thank you, Bob. And Mark, you're back up.
In the last few months, I've been chasing the challenge objects. I tried one of those. I'd really appreciate if the challenge objects were in that very small piece of sky that's accessible in my backyard. But that's not what I'm here to talk about. Heart and soul. Some are old enough to remember that as music. If you live in our part of Ottawa, there's the Heart and Soul Cafe. This is the Heart and Soul Nebulae. Now, the picture itself is not that remarkable, except for the scale. From left to right, that's about 6 arc degrees. So you can see down here, that's a Red Cat 51 and a an ASI 2600 camera to manage to get that thing to fit into frame. Using the L Ultimate filter, I was able to, I'm capturing the hydrogen alpha and the oxygen 3 lines, and then in the processing in AstroPixel processor allows me to pick those out, treat them separately, and combine everything back together again. But that's not the picture I want to show you. The first picture I got of Heart and Soul was this. And for a long time I was very proud of this, especially because what I managed to do was kludge a Minolta camera lens onto the ASI 533. And kludge is probably the right word for it. Amongst other things, I really didn't know what the aperture size was because the way it was adjusted is, well, I knew it wasn't hard one way and hard the other way. It was kind of in the middle. And there was nowhere in that train to put a filter. So given that that camera doesn't have an IR filter on its aperture, that accounts for why this is all the color, the red that it is. But again, the point was I needed a focal length down around 100 millimeters just to get the thing to fit. But this isn't the picture I wanted to show you either. When I was processing this, of course, the software will reject transients in the exposures, and you can tell it to ignore certain of the exposures. There was one in particular that looked a little odd, so I actually went through the exposures one at a time to see if I could find the one that was causing issues. And it turns out that I think I caught a meteor piercing the heart. So for those who process these things, I simply took that single exposure out, processed it separately, and then smushed them together to give you that. So there's the pierced heart and soul.
Right on, Mark. Thank you very much. All right. Richard, you're up.
Okay, so the challenge constellation for this last month was Serpens Kaput. And as usual, my backyard doesn't help me out here because of the trees and the hydro wires and so on. But we did have that lovely star party out at the Diefenbunker and beautifully clear night. But I was really busy with a lot of people were asking questions about galaxies and so on, so I was trying to show them that. But about 11 o'clock, things started to quiet down, so I did get my chance to get a picture of the sky with my Canon camera. And in this photograph, you can actually see Serpens Kaput, which is starting up here, with a triangle of stars and then sort of trailing down in this direction. But it is a very faint and obscure kind of constellation. Those are the particular stars that make it up. So I just almost got into the trees with this one too. If you want to also be looking for Corona Borealis, that was, back. Remember, we still have the challenge of finding the Blaze star somewhere in there. It hasn't happened yet. Okay, within Serpens Kaput is Messier number 5, quite a nice little globular cluster, and that was available in my backyard. This is with the C-Star S30, which I'm using quite a lot these days. It's fairly quick and easy to set up, and I'm really impressed with the quality of the pictures it can get. It doesn't have a lot of magnification, so it doesn't do so well on the small objects. For this one, the barred spiral NGC 5921, I had to bring out the planetary camera, the ASI 178 MC on my refractor. So not as good as Bob's, but you can definitely still see the bar across the middle of the spiral here, and then just a few faint wisps of the spiral arms. And I also managed to get the sextet, Seyfert's sextet of galaxies. quite an interesting little cluster there, so close together in the sky, but I understand that one of those galaxies is actually quite a lot farther away than the other, so it's not really part of the cluster of galaxies. The other ones, yeah, they are actually close together and they're interacting with each other. And I'm sorry, I didn't see the moon this last month at all. It was very low in the sky. I did notice it one night, just barely visible, so close to the southern horizon. But I saw somebody else's pictures online, and they pointed out that with the moon being so far south this season, you do get a glimpse of the north pole of the moon. So if any of you are looking in the next couple of nights, the moon is still in a similar kind of location, very low in the south, and you should be able to see the north pole, therefore, of the moon. So those were the observing challenges for last month. We did have some people actually manage to find some. I found online on Facebook, Gary Boyle had actually posted a nice picture of the moon with Venus on May 18th. Tony Jarrett also captured a really spectacular image of M5 using a remote control telescope that's located in New Mexico. So take a look on the Discord server for that one. And of course, gold stars for Bob Olson tonight for showing off the two galaxies as well. So for this next month, let's move over one constellation. We had the Serpent, and now we have the Serpent Bearer, Ophiuchus. A huge, huge constellation, and it's nicely placed at this time of year. The bottom part is fairly far south, but it stretches way up in the sky. And, you know, it's roughly the shape of a house. So Ophiuchus is a great place to prowl around looking for globular clusters again. So the second level challenge is the Messier globular clusters 10, 12, 14, and 107. So take a look for all of those Messier globular clusters. If you're just using binoculars, take a look at this corner of Ophiuchus. Now, this is a group of stars, a real cluster of stars that seems to have been neglected by all of the major catalogs. It's not a Messier object, it's not a Caldwell object, and yet it is fairly well known. It looks a bit like the Beehive cluster in Cancer. A very well spaced out cluster of stars, but very distinct and quite pretty to see in binoculars or a small telescope. Quite easy to find, as I say. It's right near the top of the constellation, so you should be able to see this big triangle of stars here, and look at near this corner, and you'll definitely see a lovely cluster in your binoculars. And for the most challenging area, this is one that I've been challenging myself with for many years. It's right down almost in Scorpius, and in fact it kind of overlaps here. It's well known as the Rho Ophiuchi Nebula, but Rho Ophiuchi is a nice little sort of triplet of stars, and it's surrounded by a kind of blue nebula. Now, blue is not a color that our eyes are very sensitive to in the dark. So no, you're not going to see it visually, but it makes a beautiful object for astrophotography. And that whole area stretching off the page down here in Scorpius all the way down to Antares is a wonderfully colored area of nebulosity. So it's a lovely, lovely thing to take a photograph of if you can possibly do it. But it's so low in the sky in the shortest nights of our year that it's very, very challenging to try and get sufficient exposures on this area. I'm working on it right now. I'm also have access to this telescope in New Mexico, so we've been getting some exposures from a bit farther south, and we're hoping to show some pictures of that next month. So those are your challenge objects for this month. For the solar system, we saw Venus. We saw Venus and the Moon last month. Well, Venus and the Moon are actually going to come even closer together this month. And on June 17th, the Moon will actually pass right in front of Venus, but around 4 to 5 o'clock in the afternoon. So this is going to be quite a challenge to actually find them in the afternoon sky. If you do, please be very, very careful. The sun will be up. You don't want to be trying to point your telescope at the sun. But if you can block out the sun with a building or a tree or a telephone pole or something like that, try and aim where Venus and the Moon are going to be, and you might be able to see the Moon passing in front of Venus. Later on that night, they'll still be very, very close together. June 9th is going to be the closest approach of Venus and Jupiter in the evening sky. But for this first week of June, take a look, any clear night, look to the west just after sunset, and the two bright objects right there in the evening sky, Venus and Jupiter, getting closer and closer and closer until June 9th. Now, I have another challenge for you this month. This is not related to observing, but it's based on something that happened in my life this last month. Sadly, one of the other organizations that I belong to, a retired teachers organization, had to shut its doors. We had to shut down because we just weren't getting enough people to volunteer to manage the group. Now, I would not want that to happen to this organization, so my challenge to you this summer is try and think about how you can participate more actively in this organization. We always need more volunteers. We always need more help. So think about it. If you want this organization to keep on being such a lovely place for us to meet and share ideas about astronomy, there's organization, there's work that needs to be done. Please help out. Please volunteer. By September, think about what particular job you could do to help this organization. And come and talk to the members of the executive, come and talk to the people who are doing those jobs right now, saying, how can you help them? And by December, where we have our AGM, I hope to see some more people, some new people being brought into our organization, being brought into the running of this organization so that we can keep on going into the future. So there's the real challenge for the summer. Thank you.
Thank you, Richard. All right, public star parties. Coming up, we had our one in May on May 22nd, and Richard made an excellent point. We had a lot of members come out with telescopes, but in terms of traffic control and greeting and that, it was me and Depinder. Now, we had a great time, but I feel bad for Depinder because he moved into his new house that day and he was showing me pictures. He was probably going to have to sleep on the floor when he went home. So if you can help out with greeting and traffic control for our next star party on June 19th, with the rain day being June 20th, that would be fantastic. Would really appreciate that. Other star parties, public star parties, are scheduled for July 17th, August 14th, and September 4th. For those of you who don't know, they take place at the Carp Library next to the Diefenbunker and typically start around just after dusk and run for a few hours. Oh, details are right here. Ottawa Public Library at Carp at 3911 Carp Road, so you can plug that into your GPS if you're not familiar with where the Carp Library is. And typically, about 8 p.m. to about 10:30. And we had a great turnout last month. We had about 60 carloads of people, but what was really fantastic is we got a lot of families with young kids and teenagers, and we had a lot of university students come out. And there was one group of young ladies, I think it was, they were all wearing Carleton Raven toques. I don't know if it was the basketball team, but they came out and had a really great time looking through a lot of the telescopes that our members had set up. All right, call for volunteers. Again, bring your telescopes. You want to volunteer at traffic control, you want to work at the greeting desk, that would be fantastic. Do reach out to Depinder. His email is starparties@ottawa.rasc.ca. All right. Our Fred Lossing Observatory, we mentioned this earlier, is located at the Mill of Kintail. You see an excellent picture here of the 3 large telescopes we have. The one with the roll-off roof, and we have the clubhouse out there, and we do have star parties for the members, which I'll talk about in a minute. But you can, as a member, you can bring your telescope out there. If you want to be trained on the larger ones, reach out to our director, Rick Scholes. Our next members-only star party at the Fred Lossing Observatory is on June 13th. Okay. And our director, Rick Scholes, his email is flo@ottawa.rasc.ca. Our new librarians are Rachel Chen and John Thompson, who have stepped in to take Estelle's place, given that she's retired after many, many years. Our Ted Bean Loan Equipment Library, Peter Schut. We have an open position for anyone who wants to make coffee. And membership info, Art Fraser. In the audience tonight, we had 43 members. Thank you for coming tonight. We appreciate it, as well as 45 on Zoom for 88 people attending tonight. Our list of organizations and speakers, and thank you to everyone who came and presented tonight. Hosts, of course, being our national office and provide us with Zoom. And any comments, ideas, feedback on our presentations, please send it to meetingchair@ottawa.rasc.ca. Our next meeting is Friday, July 3rd, same place, same time. And again, any ideas for observations or talks for future meetings, please do reach out to us at meetingchair.ottawa.rasc.ca. And that's our meeting for this evening. Just a reminder on the way out, the rest of the museum is closed to the public. And just a very quick astronomy thing, we have had a solar storm. Now, unfortunately, it seems to be very cloudy tonight, but potential for aurora over the next few nights is potentially pretty good. So keep your eyes on the skies. For those who want to get together afterwards, there's a post-meeting gathering at Liam McGuire's at 1705 Saint Laurent Boulevard at Innis. And that's our meeting for tonight. Thank you very much. Safe travel home, and I wish you clear skies.